Hello there, we're doing translating languages today. Specifically group language to additive language and multiplicative language. So we're going to see expressions that are in group language, like with star and E as the identity element, and translate them symbol for symbol into additive language and multiplicative language, which are the language that you're more comfortable with. So first, some vocabulary. So the main things we're going to translate or change into the other language are the operation symbol, the inverse symbol, and the identity element. So as you know, in group language, the operation is star, the inverse is the little I above the element name, and the identity element is E. In additive, we're going to change. If we're translating into additive language, we're changing the star into a plus. Any inverse of an element, we're changing it to negative that element. And the identity element in additive language, as you know, is 0. In multiplicative language, the operation is, of course, times. The inverse is 1 over the element, and the identity element is 1. So here's an example of how you would translate something from group into additive or multiplicative. So here's something in group, and I'm going to change it first into additive language. Oh, sorry. That should be negative C plus 0. So that is now an additive language. Every I means inverse, and in additive that means negative. Every star has turned into a plus, and the identity element is now 0. Here it is in multiplicative. So every star is turned into times. Every inverse means 1 over. Inverse, 1 over. And the identity element is now 1. Okay, now that we can translate from group to additive or multiplicative, we can translate some of the properties that we've been working with that we've only known in group so far. So first, I'll translate the identity property. So in group, the identity property says that anything star the identity element is itself. In additive language, it says anything plus 0 is itself. And in multiplicative, it says anything times 1 is itself. So these are what the identity property look like in addition and multiplication. Now inverse property says that anything starred with its inverse makes the identity element. In additive, that looks like this. And in multiplicative, it looks like this. In commutative, if you if two elements interact with each other and if you change the order, you get the same result. In addition, it looks like this. And in multiplication, it looks like this. If you put variables next to each other in multiplication without the dot, it means times. So that's understood that this is A times B, and that's B times A. Now, just today, or the day before, when you're seeing this, we proved Theorem 1, OPE, Operation Properative Equality, which says in group, if A equals B, then A star C equals B star C. In addition, it says if A equals B, then A plus C equals B plus C. And we do that all the time. When we have an equation, something equals something, we add the same thing on both sides of the equation. We do that all the time when we're solving equations. And in multiplication, if A equals B, then AC equals BC. Again, we do that all the time. We multiply something on both sides of an equation. And then the other theorem we proved today was inverse of inverse. Theorem 3, which says in group, the inverse of the inverse of A equals A. In additive, the negative of negative A equals A. And in multiplicative, 1 over A equals A. Very useful theorem, because we do this all the time. This is why negative negative becomes positive. The inverse of inverse tells us so. And then this is just the translation of the group. We do this all the time. 1 over the reciprocal of something is that thing, because inverse of inverse says so. Okay? There are more properties you can translate, some you can't translate, and we'll do the rest of those in class.